Okay, as you saw in the Bill Nye thing, how this is what they're doing. So it depends on the materials that you rub things on how they react. Like glass, um, glass uh, takes on the animal fur. It takes the electrons off and puts them on the gosh dang, I can't even talk. In other words, on the glass rod, it's neutrally charged, and so when you rub it with the fur, the electrons come off the fur, and so since the electrons came off the fur, that makes it positive, positively charged. Now, when you rub the ebonite rod on your hair, or with the fur, this ebonite rod, when you rub it on the animal fur, it actually collects the electrons on the outside, and a lot of and the electrons on this end come running down, or probably even run up your hand here, run to ground. All right, so the excess electrons on here will run to ground, and so you get the ebonite becomes negatively charged. Okay. In the law of constant, during any process, the net electric charge of a system will remain the same. In other words, the amount of charge that's on the fur and the rod will stay the same. They'll just reorient themselves, okay, due to charging by contact, which is in this case charging by induction, where we get it close. Um, like charges repel, unlike charges attract. Okay. Um, Conductors and insulators. Things that are good conductors are also good conductors of heat usually. Okay, that's why we don't. That's why even though it works pretty well, when you're making s'mores, never use a hanger for s'mores. All right, unless you're wearing an oven mitt. All right, because a hanger works great for s'more. Because what happens with a wooden stick? It burns up in the fire, and your marshmallow falls in the fire, and all that. You had it perfectly brown. The stick burned in half. Boom! It falls in the fire. That sucks. But if you use a hanger, you better have an oven mitt on, or have a wooden handle, a bad an insulator type thing that does not conduct heat very well to hold on to. Things that are usually things that are good conductors of heat are also good conductors of electricity because their electrons move. Okay, so here's an ebonite rod. This is charging by contact, where you actually touch the rod, charged by contact. Okay, now look what happens. The charge gets on the outside of the sphere uniformly. Okay, uniformly forms on the outside of the sphere. An ebonite rod charging by induction. We've got this ebonite rod. We bring it in here. Now look what happens. Look what happens. The electrons that are on the rod that were associated. Now, before we brought it in here, all these electrons were matched up with these protons. Okay, it was neutrally charged. Then we brought this ebonite rod in. These guys went running to the other side. They go, whoa, we're running to the other side. Electrons are the things that move. Protons don't move. Protons jiggle. Electrons move. Okay, protons jiggle. Electrons move. Remember that. All right. So anyway, so you bring this over here. Now we're going to attach a grounding wire. Why? Because the ground is positively charged, all right, due to the iron core of the Earth. Our geoscience students know that better than I do. And look what happens. These excess electrons go running to the ground, and that leaves us with excess positive charge here. That's induction. Okay. So we can also charge by inject. Now, a positive surface, when we're doing a balloon, when we bring a balloon in, okay, and it sticks, that's what's happening, because on the surface, this plastic, very neutral, but the actual atoms, the electrons on the atoms move to the inside. And so it leaves the surface positively charged, and the ebonite rod is here. And so that's why when we rub electrons onto it, they'll stick. If I have something that's light enough, like a balloon, I can rub a balloon on my hair and then hang it on a plastic wall, or hang it on a shower curtain, or hang it on even a regular wall. Okay, it'll hang. In fact, let me show you the John Travolta video on this.